All right, and we are officially recording. And someone said, I thought this was a happy hour. Where are your drinks? Well, I'm drinking coffee, kind of late in the day for coffee, but here we go.
Yeah, and hopefully Lisa has a drink because I now have to drive and pick up that cat. And I just got a text from Bob saying, you know you're live? Yes, it's okay. All right. Well, happy hour, everybody. Welcome to Citizen Science at the Union League. I'm Darlene Cavalier, wife of Bob Cavalier, and the founder of SciStarter, which is a website that helps people find citizen science opportunities to engage in. We're going to talk about what citizen science is, and I am joined by two guests. Caroline, do you want to introduce yourself, and then Lisa?
Definitely. I'm Caroline Nickerson. I'm a program manager at SciStarter, and I'm so excited to talk to you all about citizen science.
And I am Lisa Dallas. I work at NASA's Goddard Space Flight Center, and I am the Data and Information Systems Manager for the GLOBE program, which I'll be speaking about in a few minutes.
All right. So.
Yes, and Lisa and I are both members of the Union League. So we actually had a chance to meet up in a real happy hour in person a couple of months ago, and I'm really happy that we have this opportunity to allow our professional sides to kind of shine at the league as well, and hopefully provide some neat ways for people to engage from home or using social distancing measures to also contribute to important scientific research while you have fun. Okay.
Great. So, and for those of you who just joined us, please feel free to put questions in the chat as we go. We want to interact with you. We want to make sure that we're answering your questions and that you get something out of this too. So we're going to go ahead and launch this poll. We just want to know, have you heard about citizen science before? I know the answer for Bob is yes, but for everybody else, have you heard of it?
And Lisa, since we're panelists, we actually can't participate in the poll, just in case you were trying to.
Okay.
We got a few yeses, a few nos, but no one's unsure. That's good. So I'm going to end the poll and share the results. So mostly yes, a few nos.
Oh, that's good. All right, so we're kind of in the middle there. That's great. Thank you.
And for the people who said yes, we want to know, have you actually done a citizen science project before? So we're going to launch this poll. Let's see what the people say. Okay, we got one no. Another no.
Great. This is the time then.
Yeah, I mean, well, that answer is going to change today because we're going to be doing some citizen science together on this call. A few yeses. Okay, last chance to vote before I close the poll. And we're going to end the poll. All right. Oh, we got one more vote. And now we're officially going to end it. So majority no's, but a few yeses.
All right, and then for the yeses, if you feel comfortable putting in chat the type of project or the name of the project, if you know it, that would be cool too, so we can understand what you're interested in. And then in the interim, we'll go on with the show here. I'm just gonna make my screen full size and take you through this talk about what is citizen science. So we know, and you probably know too, that millions of people enjoy science and nature. When I used to work at Discover magazine, we had 7.4 million readers of that magazine. Which was kind of mind-blowing because most of them did not have college degrees and hardly any of them had science degrees, and yet they were subscribing to a magazine that was all about science, technology, and nature. So millions of people enjoy science and nature. And it turns out thousands of scientists need their help, your help. Next. It's not always easy for them to find each other. So we connect them. This is exactly what we do at SciStarter, and we'll get into that in a bit too. So typically, citizen science is basically a collaboration between professional scientists, people who hold degrees in formal fields of science, and the rest of us, including myself. I do not have a formal science degree. Lisa does. But the rest of us who are curious and concerned about issues in the world, and citizen science allows us to take action on those issues. You just need to be curious or concerned, but this, I guess the special sauce is they have to actually make the effort to get involved in these projects. Next. So citizen science is very different than typical STEM programs, which you may or may not have heard of. These are science, technology, engineering, and math programs. Usually when we hear of STEM, it's associated with educational efforts, usually aimed at kids. Well, citizen science, the main thing that's different is that somebody is using your data. So it's not just a program that you do to learn about science, although you can in the process. You're actually contributing to advancing important areas of research. So somebody you know, and we now know that a couple of us on this call are citizen scientists. This eBird is a very popular app that people use for bird watching. Many bird watchers are citizen scientists. They may not have gone into bird watching to become a citizen scientist, but by the very nature of the tools that they use, they're reporting their data and sharing their observations with ornithologists and with others, and they become citizen scientists. That 1.5 million reports, was that 1.5 million, Carolyn? I can't actually.
That's right, 1.5 million.
Okay, that's just in January alone. So there's a lot of people who do that project. Water testing, maybe some of you have volunteered to monitor our nation's river, streams, or lakes. You are a citizen scientist too, because if you share that data, you become a citizen scientist. So imagine 1.5 million, an estimated 1.5 million people in the United States who volunteer to do that annually. And then there's other types of projects like SETI at home. This is more of a crowdsourcing kind of project where you download software and you allow your computer's spare processing time to be used by scientists to basically search for life in space. Next. And citizen science has economic values as well. There's an estimated about 1.3 to 2.3 million citizen scientists had an economic value of $2.5 billion each year. And that was done on a study of 338 citizen science projects, mostly within the ecology and environmental science projects. On SciStarter alone, there are roughly 3,000 projects. So the economic value of citizen science, multiply that by, I guess, 10 or so. Next. And citizen science is definitely serious science. Real stuff happens because of your efforts, the collective efforts of people involved in these projects. Because of citizen scientists, we know birds breed earlier than they used to. We know that there are 50 types of bacteria that live in your belly button. We know this because people submitted swabs from their belly button to scientists in North Carolina State University who studied all those microbes and determined that on average, there's more than 50 types of bacteria that live in your belly button. And it's not just for fun. They go on, they publish papers, and then they inform new fields of research too. Half of what we know about migratory birds and climate change is strictly because of citizen scientists and the data that we produce. Next. And citizen science is at a bookstore near you. Shameless plug, but I also think the reason why we wrote this book is the same reason why we're doing talks like this. It's to introduce people to the wonderful world of citizen science. That's a picture of me and my mom at a local bookstore here in Philadelphia called Head House Books. So the Field Guide to Citizen Science came out a couple of months ago. And this is a way that we can introduce you to 50 different projects, kind of divvied up by topic and by activity level, and things you can do in the summertime and things you can do with grandkids. And it steps you through each one of those projects and the instructions. It also summarizes some of the scientific output from citizen science and looks forward as well, like a little bit of foreshadowing to what's to come with citizen science, which involves people actually creating low-cost instruments and finding ways to deepen their engagement in science through citizen science. Next. So I mentioned there's more than 3,000 citizen science projects and events on SciStarter. So this is SciStarter.org. It's a research affiliate of Arizona State University, where I work, in the School for the Future of Innovation and Society. It's also a research affiliate of other universities, including North Carolina State University. SciStarter works very closely with organizations who reach people across the spectrum of their life. We really believe in lifelong learning and making sure that we're able to reach people in all those different segments of life. From young girls as Girl Scouts, we have a very nice formal partnership with the Girl Scouts where girls can earn a badge. It's actually called a journey through the Think Like a Citizen Scientist journey, all done through SciStarter. It's very cool because they do a project and then they tell people about the projects that they did, and then they need to take action on that project too. So we're super proud of that project. Then we move on to grade schools and high schools where SciStarter is used heavily in formal learning environments as well as informal learning environments, including Libraries, we do a lot of work with libraries to lend out tools and instruments. But on that note, most projects, you don't really need much more than your phone, potentially an app, which Lisa's going to describe later. But typically, you don't really need specialized research. For some projects, you do. If you're interested in monitoring weather and precipitation, we'll show you how to find the right rain gauge to get involved in a project where your data actually is shared with the National Weather Service, and it's used to predict droughts and floods. Really important reasons to have that. And we have gardeners tuning in here. My goodness, there's so many projects that you can find that won't take much extra work on your part beyond what you would be doing to garden anyway. So maybe you already observe pollinators. Well, there are scientists all over who actually need your data to understand the changes in pollinator counts and where that's taking place. So this is what SciStarter looks like there. And I should also mention that we do work with Verizon. We're one of Verizon's platforms where the employees get to earn volunteer credit time by doing citizen science through SciStarter. We help them track all their hours for that. And we also work with OSHR, which is a lifelong learning institute for senior citizens. And we're training senior citizens to become trainers in their communities so that they can spread the word of citizen science and help other people get involved in these important projects. Many projects are local, so you can get involved in something, as I mentioned, from your backyard, from your house, you name it, there is a citizen science project that needs your help. But also many are global, so you may be contributing and participating locally to a project that has global implications. Actually, there's a lot of projects like that too, and you can search for them all. We're going to show you how. Next slide. This is how. There's an advanced project finder where you can go crazy. You can select the age group. You can select things that you can do while at the beach or while you're fishing. You can select things by keyword or phrases, and certainly your location. Next. Now this becomes important here for the Verizon platform, for others that need evidence of their contributions, or they just want to be able to see all the things that they're involved in and all the ways that they're contributing to these projects. SciStarter, we don't create the projects, and we typically don't house the forms for those projects. For maybe a dozen projects we do, what happens is you find a project that you're interested in because we've organized it from all over the web. Remember that slide about it being sometimes difficult for would-be volunteers to find these opportunities to engage, to actually match up with the scientists? This is our whole role. So we take projects from all over, including importing from a federal database of projects and from other nations' inventories of projects, and we organize them, we make them look nice here, and then we allow you to pick one, you go to that website or you download that app, you engage in that project, but hundreds of those projects use special tools that, with your permission, report back to SciStarter how frequently you're engaging in their project. We store all that for you in your dashboard, which is good on its own. We know that this helps with motivation, keeping people sustained, and also maybe finding new projects to get involved in. And typically people who do one project go on to do multiple projects. But it's also very useful for the Girl Scouts and the schools and some of the other programming that we mentioned where evidence is needed. And now we're starting to move into accreditation for some of this work as well. Next slide. Now I'm going to actually toss it back to Lisa. And Lisa, if you can just reintroduce yourself in case somebody joined us late, and take it from here.
All right, thank you, Darlene. And again, I just really want to thank you for inviting me to speak about NASA's Globe Observer app, which I think, along with all these other projects, is a great way for people to engage with citizen science and contribute useful data that's used by the earth science community. So I was just curious how many people have been to NASA Goddard or have even actually heard of it. I think when people hear NASA, they typically think of Kennedy or Johnson Space Center, but Goddard is actually the largest of NASA's 10 field centers in that they employ the greatest number of civil servants, which right now is about 3,200. And it's also our nation's largest organization of scientists, engineers, and technologists who build spacecraft, instruments, and new technology to study the Earth, the Sun, our solar system, and the universe. I've been working for Goddard since 1984, And since 2017, I have been serving as the Data and Information Systems Manager for NASA's GLOBE program, which is the umbrella organization that created the Globe Observer app. And just as a little bit of background here, I wanted to speak a little bit about the GLOBE program because it is a 25-year-old program that was started in 1995 by the US government with NASA as its primary sponsor. We also receive support from the National Science Foundation, from NOAA, and from the Department of State. And GLOBE stands for Global Learning and Observations to Benefit the Environment. It wouldn't be a NASA program unless it had an acronym. But it is an international earth science education program that's targeted primarily to grades K through 12 and is currently used in 123 countries. The program teaches students how to take measurements, earth science measurements, in approximately 50 science, what we call protocols. And these observations range throughout all of the 4 Earth spheres, including the atmosphere, hydrosphere, pedosphere or soil measurements, and biosphere, which includes vegetation and plants. We offer a website that has a rich set of materials for protocol instruction and also teaches students in the scientific process, including how to formulate great research questions, how to conduct research, collect data, and report your results. So in addition to that, GLOBE sponsors what we call our International Virtual Science Symposium. So we have students that formulate a research project and present their results. And these IVSS projects come in from all the countries that participate in GLOBE. We have subject matter experts that evaluate the students' research projects, and we recognize those projects with significant distinction. We also conduct science symposia in the 6 regions of the United States. So this gives students, you know, we have the younger grades participate, but it's primarily high school students, and they get to present their research at a symposium, so they get a feel for what it's like to actually present results in a professional setting. So back in 2016, NASA headquarters decided to extend the GLOBE program to include citizen scientists, and that's when we came up with the Globe Observer program. So, oh, I see the poll here. Okay, so very few people have been to Goddard. I highly recommend that you take a visit there when things start opening up because it's a very fascinating place. They do have a visitor center, and there's a lot of great research that happens at Goddard, a lot of great stuff to see. So I guess we can just close the poll here. And then this slide is an overview of the Globe Observer app. So the app contains 4 tools where you can take earth science measurements in 4 different areas. So I'm just going to talk about each area briefly. But what is common to the app is that it's available for most Apple and Android mobile devices. Each of the different tools contains a short training or tutorial that assists users with data entry. So the tutorial will explain why the data is being collected, and it teaches you how to properly collect the data. Sometimes I think there's a little bit of hesitancy with citizen scientists in that they're a little unsure about the quality of their data. And if you step through the tutorials that we provide, you will definitely be submitting high quality data that will be used by researchers. The Globe Observer has its own website, and you can see the URL at the top of the slide there. And in addition to information about these 4 tools, it also contains a number of educational resources and hands-on activities for at-home science, as well as other information like our news and events. An example of that would be we occasionally run what we call data challenges. And last fall we had our Fall Clouds Challenge, which was called What's Up in Your Sky? And that's when we encourage people to take observations for one of these 4 areas. We emphasize that we'd like increased participation for a certain period of time. So the Clouds Challenge happened in the fall. It took place over a month. And we asked people to sort of amp up their cloud observations for that time period. And at the end of the month, we actually received 43,000 observations from across 93 different countries. So we were thrilled with that level of participation and obviously collected a lot of great data from that. And one other thing I forgot to point out is that in this 25-year history of GLOBE, we have collected over 183 million observations from students across the world. So when you compare that number to, I think it was eBird where you said it was 1.5 million, 183 million is a great reflection of the long history of GLOBE and the level of participation. So the first tool that we included in the app was the Clouds tool, and that provides users a way to identify conditions in their local sky. You can report whether you have a clear sky, a cloudy sky, or if your sky is obscured, and that could be for any number of reasons. Could be smoke, could be dust, fog, etc. So the app allows you to classify the type of obscuration. You can also identify the percentage of sky that's covered by these different things, whether there is a presence of clouds and contrails in your sky. And then you also have the opportunity to classify the different clouds that you observe in your sky. And that's where we just launched a new tutorial that basically walks you through the classification of each cloud type. Our Clouds tool was one where I would say our users were a little bit unsure about the quality of their data, but now with this new tutorial, it really steps the user through such that they're confident in how they're classifying these clouds. And once you've gone through this tutorial a number of times, you can probably bypass it because you will become a cloud expert and you'll be able to just quickly identify the types of clouds that you see. In addition to the ability to classify what's in your sky, the app also provides notifications to users when a NASA satellite will be overhead. And if you want to match your observation to what a NASA satellite records. So if you opt to do that, you can set a notification on your phone and it will tell you when one of NASA's either Aquaterra or Calypso satellites will be overhead in your area. And if you take your observation within 15 minutes of the overpass, you'll receive an email from NASA that basically describes the satellite match to what you recorded. So you see on one side what the satellite recorded and what you reported in your sky. This clouds data is very valuable to NASA cloud researchers, especially because with these satellites, certain cloud types are really difficult for the satellites to observe, especially cirrus clouds, which are the thin, wispy clouds. So reports from users on the ground are very useful for these researchers because the satellite can't capture that data. You're also getting top-down views from the satellites. So Globe Observer Cloud observations provide an additional source of data at ground level. And recently, as I said before, where you can report obscurations in your sky, one of the types of obscurations are dust storms. There is a group of dust scientists, and I should say also that I'm not a scientist, I'm a computer scientist, so I can't really speak too much about the earth science aspects of all of this, but we do have these dust researchers that study this data, and when they discovered that we had these observations reported with the Globe's Clouds tool, they were very interested and contacted the Globe program because they want to work closer with us and utilize those observations that are in the database. So the next tool that we launched was the Globe Mosquito Habitat Mapper, which is a very interesting kind of specific tool. As I'm sure everybody on the call is aware, millions of people die each year from contracting mosquito-borne diseases such as malaria, Zika, and dengue fever. And we have satellites that perform observations that identify environmental conditions where mosquito populations can flourish, but these ground observations submitted by the Globe Observer Mosquito Habitat Mapper tool provide ground truth that validate these predictions. And the way briefly that you use the tool is that we ask users to identify and photograph potential mosquito breeding sites around their area. And these are areas where water collects, such as ponds, pools, open containers, etc. Once you photograph the breeding site, we ask you to eliminate it if possible. So if it's a standing water container, we ask you to dump the water out. You can optionally collect water samples from these breeding sites. You can count any mosquito larvae that are present in the sample, and you can also identify the mosquito larvae using a zoom lens on your cell phone camera. This is a really interesting project because Globe has partnered with the Department of State for what they have called the Globe Zika Education and Prevention Project. And this project works with citizen scientists and public health officials in 30 Zika-affected countries to engage these hard-to-reach at-risk populations in the identification and elimination of these mosquito habitats. Our third tool that we launched was the land cover tool. And contrasting to the clouds and mosquito tools where you can take multiple measurements throughout the day, land cover is one that you don't use as frequently for a given area, but it does allow users to classify approximately 100 square meter area in terms of the land cover. So you would indicate the types of vegetation that you see, or the ground conditions, whether it's grass, asphalt, the types of trees, shrubs, etc. So once you step through and classify the different things that you observe in this area, the app will calculate a land cover type based on an established classification system and enter that into the database. Users can compare what they have classified a certain parcel of land to be against what the MODIS satellite classification has determined that it is. The MODIS satellite, however, classifies parcels of land that are 500 meters square. So what you're observing with the Globe land cover tool is at a much smaller resolution, and there could be some discrepancies there. So this allows the users to flag these discrepancies, and it gives researchers a higher granularity of data in terms of what is actually present in the land cover. And land cover data is a useful predictor of risks for natural disasters such as landslides, floods, or fires, as transformations in land cover due to shifts in land use or climate change can affect rainfall and temperature, which in turn influences the incidence of these landslides, floods, and fires. And then the last tool that we have in Globe Observer is Globe Trees, and that allows users to observe trees in their local area and measure the height of these individual trees. And if you step through the tutorial, it will tell you exactly how to do that. But basically, the height is calculated based on the user's distance from the base of the tree, and then the camera angle when you point from the base of the tree towards the top of the tree. So, you know, fancy geometry will calculate the exact height of the tree. And with all of these tools, the user has the option to submit photos that will corroborate their observation. And in particular with, let's see, clouds and land cover, they ask for directional photos, and the app will automatically indicate when your camera is pointed due north, due south, east, and west. So you don't have to figure that out yourself. The app will assist you with aligning your camera appropriately. So that's, you know, an overview of Globe Observer, and if anybody has any questions, I'd be happy to answer them. You can, I guess, either, I don't know if participants can contribute verbally or if they only can contribute via the chat, but happy to answer any questions.
All right, thank you so much.
It is only by chat right now, but hang on until the end and we'll open up the mics. How's that?
Sounds good.
Okay, great. Thank you, Lisa. It was super informative. We love the Globe program. All 4 protocols are super valuable, and we highly recommend downloading the Globe Observer app on your phone. It's a free app, and just get started with one or more of the protocols. I think you'll really enjoy that project. And as you heard from Lisa, it has super important research implications too. All right, let's move on to Starcatchers. So we're going to do this project together.
Yeah, for those of you who said you weren't citizen scientists, now you are. You're about to do a citizen science project.
That's right. Everybody's going to do this one collectively with us, even though Caroline will be actually entering the data. It's going to be crowdsourced from everybody who's patched in here. So Starcatchers is an online gamified project. That means that there's gamification that's part of this, and there's also a lot of quality assurance that's baked into this. So it's a program where you'll be looking at very short video clips of blood moving through a vessel in the brain of a mouse. I'm sure there's a better way to say that. That mouse has been infected with Alzheimer's. This program, this research project, is led by Cornell University, where they have graduate students who spend a lot of time looking through these short video clips and determining how many stalled blood vessels there are. So the reason why that's important is because the same group and others are looking at experimental drug treatments that indicate when stalls are removed from that mouse brain, memory is restored. So it's a very exciting area of research, and they need to get through all of this data. So it lends itself very well for crowdsourcing and citizen science. And sometimes those terms are used interchangeably. So in this case, Caroline is going to walk us through looking at actual videos, and we're going to determine whether or not we think there are stalls in that blood vessel or not. And you'll see how simple this is, although it does take a little bit of time. So when we're finished our event here, we're going to show you how to access all these projects. And at least for me, it did take a fair amount of practicing, a little bit of training to feel a little more comfortable in identifying whether or not the blood was stalled or flowing. And also, before we get started, I mentioned the data quality considerations. In many projects, that's taken into account, both to help you feel more comfortable and confident and sustain your engagement in these projects, and also because nobody wants bad data. So in this case, 10 of us have to be looking at the same video clip and see the same thing before that's considered research grade data. And then that short video clip is moved over to Cornell as research grade data. What we did last year, we just came off the heels of Citizen Science Month, which was all of April. Caroline coordinated something like 115 or so. I'm not sure how many online events she did that were supposed to be in person, but congratulations, Caroline, you survived. Last year, we had Citizen Science Day, also supported by the National Library of Medicine. And we had lots of people do the same project at the same time. So, and we kind of stretched it till over a weekend. We had people all over the world engaged in this program, Starcatchers. And we then measured with Cornell, were we able to accelerate any research? Mind you, it had to be 10 people seeing the same thing on one short video clip. And it turns out that the amount of research amount of data that we analyzed, which is what we're going to do together, equal the amount that would have taken that research team. Was it 4.5 months, Caroline?
Yeah, it was the preliminary result for 4.5 months.
4.5 months that we took care of in basically an hour, even if we stretch it out till a weekend. So citizen science definitely accelerates important areas of research. So enough with me talking. Caroline, do you want to take it away and tell us how we can kind of crowdsource answers and get involved?
Let's do it. So I'm just going to go to Starcatchers. We'll get more into this page later, but this is just a handy way to find Starcatchers. The beauty of Starcatchers, it's a SciStarter affiliate. So that dashboard that Darlene showed you earlier, if you sign up for Starcatchers with the same email that you have for your SciStarter account, your contributions, the number and frequency of them, will show up in your SciStarter dashboard. I just like to do that for bragging rights, but it can be built into all those different programs that Darlene described, like the Girl Scouts, the OSHA program for, lifelong learning, all sorts of different programs, so people can get credit for volunteering their time to advance research and make the world a better place. So I'm already logged in. I'm on Team ASU right now because Darlene and I did an ASU event recently, but you can also join Team SciStarter. And Darlene mentioned that this is gamified. So I get points for the blood vessels I classify. And they've been really smart with this project. They've built in this thing called machine learning to the project itself. So as you can level up as you go. Your contributions can count for more points depending on, they get this many correct, or, they've done this much, they have this much experience. But the beauty of Starcatchers is you don't have to worry about getting something wrong, because like Darlene said, so many different people are looking at this and classifying it that the power of the crowd really prevails. And we're all in it together to get a research response. So you're essentially collaborating with all these people you see here. This is the leaderboard for some of the Supercatchers. My favorite username is BadStalls, he's always up there in the top 3. But there are all sorts of people all around the world who participate in Starcatchers. So I think the best way to learn Starcatchers is just by doing it. So we're going to go ahead and make a classification together today. So I'm looking at this video of a mouse brain, and as you can see, it's playing on a loop. And they want you to look in this circled area, this orange circle right here, and they have kind of a blood vessel area of interest. So it's totally okay to be wrong. You don't have to be perfect at Starcatchers right away, but you try to identify whether or not there's a persistent black spot in the flow of white. So that persistent black spot would be a stall. Oh, it looks like somebody said something in the chat. Let's see.
That's Lisa and John saying hi to each other.
Oh, all right. I love it. Yeah.
Debbie, I'm glad that Debbie tuned in and she likes the talk so far. Hi, Deb.
That's awesome. So this right here, I'm going to go ahead and classify the first one for everybody. This is flowing. And oh no, it's leveled me up. Okay, our next one's going to be even harder. Are you ready for it, everybody? Let's go to our next stall.
Again, how you knew that was flowing.
I did not see a persistent black spot.
Okay, so persistent black spot means that it's stalled. The blood is not flowing through, it's stalled. Is that what that means?
Yep, and this one's a major stall. I can already tell right there, there's a stall. So you see how there's a spot that kind of just stays black, it never turns to white. This is gonna be really embarrassing if I'm wrong. Oh, nope, I don't think it's a stall after all, because you can see that it turns white here. So that's the beauty of this little scroller. You can scroll it at your own pace to get kind of a closer view of the blood vessel. So I'm going to say this one's flowing again before I let everybody vote. Let's see. Yep, it's flowing. All right, now we have another one. So everybody, let's look at this circled area right here and this blood vessel. And I'm going to have you vote in the chat, and I'll let Darlene kind of keep the count of the votes about whether or not you think this is flowing or stalled. So you look at this flow of white right here. Do you see any persistent black spots? Do you see any spots that never turn white? Because if you do see those black spots, there's a stall. So go ahead and put in the chat stalled or flowing, and Darlene will give me the verdict, and we'll have made our first classification. So what does everybody think? Stalled or flowing? It's okay to be wrong. Any answer is good. You have a 50% chance of being right.
And this one, Lisa, you can weigh in on this one. You can comment if you want to take a guess.
All right.
Darlene, what do you think? Do you think this is stalled or flowing?
I put in stalled. But
You think stalled?
Evenly split, Caroline, right now. Let's see, we have, well, all right. Bob, the Cavaliers, 3 Cavaliers say stalled. And hey, Marla, hey, Kira. Everybody else says flowing. So we have 3 and 3.
Okay. Lisa, I'm gonna let you be the tie. Do you think it's stalled or flowing?
Oh, I thought I put my vote in. I'll go on the flow side.
You're on the flow side.
Yeah.
All right, let's go with flowing. And we're correct, it's flowing.
All right, Cavaliers, we've got to get our act together.
All right, let's do another one. As you can see, some of the videos are a little better than others, and that's just how science works. You have different quality of data for different things. If some of you end up doing Starcatchers more regularly, This team, the team that runs Starcatchers out of Cornell, they are so good about reporting back the research results. I remember one that really intrigued me recently was they found out that exercise did not reduce the incidence of stalled blood vessels in mice. So basically, exercise counterintuitively did not improve like brain functioning in mice that had been infected by Alzheimer's, which you would think it would be the opposite. So there's Starcatchers giving us the important research results we need. So what does everybody think? Stalled or flowing? I'll give you a few seconds to vote. Look inside this circled area and see if you see any persistent black spots and kind of the flow of white.
I'm going with Marla here. I say stalled.
You think stalled? Does everybody agree with you, Darlene?
I don't know. I wouldn't.
All right, let's say stalled. And you are correct, 19 points.
Nice.
And as you can see, the community can comment. So we're gonna say the Union League, no, we'll say the Cavalier clan. I'll let the Cavaliers take credit for this one. All right, the Union League believes it is stalled. Oops, I commented too quickly, okay. In Philadelphia, there we go. And as you can see, my contributions are also credited in my SciStarter profile. All right, let's do one more before we move on to another project.
This one is also a great project because it's very popular for intergenerational collaborations, I guess. And in this era where a lot of grandparents are staying home, you can create a team between grandkids and grandparents and play this online together. We've seen really cool things happening in different communities with this project too. So, all right, Caroline, this one looks interesting.
This one's kind of hard. I'll let you all decide. Do you see any persistent black spots in the flow?
That one is a hard one. I'm gonna say flowing, just because I can't.
Flowing?
And hopefully 9 other people are better than me and I just didn't ruin data.
All right, let's do flowing. And we're correct. We leveled up again.
All right.
So we'll stop with that for now. Darlene, do you want to do spiral graph for now?
Let's do it. You'll lead that one too. Have you done spiral graph, Caroline?
I did. I was so everyone, we did a webinar recently with Arizona State University, and my partner put me on the spot, not Darlene, our other partner, to do this project for the first time and map a galaxy. But we did okay. So
this
a little bit more experience now.
Stay on this page for a second too, Caroline. This is one of the online events that Caroline ran with Astronomy Magazine during Citizen Science Month. We had 3 scientists come on and talk about different astronomy-based projects. And I just want to highlight them because they are pretty darn cool. One is Globe at Night. So you can go out and you can measure light pollution. So here in Philadelphia, it's kind of hard to see the Milky Way because in part of all the light pollution that's out there. So you discover how to report and monitor light pollution by counting the stars that you should be able to see in a constellation. And those that you can't help give an indication of how bad light pollution is where you are, or in some cases, how okay things are if you can see that full constellation. The middle one is called Satellite Streak Watcher. And this is a new project put up by Lisa. His name is Sten Aldenwald at NASA. He created this project to help people actually use their cell phones to take pictures of the streaks that satellites make in the sky. So that's a cool one. And Caroline is going to talk us through spiral graph. And Caroline, actually, I'm sorry, can you go back once more? On this page and many other pages on SciStarter, you can do this tutorial at the bottom. It's a self-guided, what is citizen science, some baked in quizzes, some reinforcement. It's actually a really good way to introduce more people to citizen science. So even if you just look at SciStarter and look for what is citizen science, you'll find that tutorial. But we're gonna send all these links to John Miko, and hopefully he can send them out to everybody who registered too. All right, Caroline, take it away.
All right, so we're gonna do spiral graph today. This project's actually, it's hosted on Zooniverse, and the people who run it are based in North Carolina. And I think this project especially, it demonstrates kind of the diversity of citizen science because it's everything from astronomy to zoology. You can be part of literally every type of science that exists. So if you're a curious person, and I think a lot of you are, you can really satisfy that with citizen science. There's a tutorial on spirograph. We're going to skip over it now in favor of just going ahead and tracing the arms of these photos of galaxies. So they need it. That's why the researchers need it. You know, they need us to help them classify these pictures. So tracing arms, you need to trace at least one arm. And I'll be honest, I don't know everything about this project or about astronomy, but that's also the beauty of citizen science. You don't have to be a professional or know every single detail about the hard science to be able to make a meaningful difference and move the research forward.
And Caroline, are you just doing this with your cursor? How are you doing this?
I'm clicking through the tutorial really quickly to give people, to show people, but we can go ahead and actually classify the galaxy. So we're going to select smooth or merging if the galaxy gradually fades in all directions from the center, or it appears to be merging with more galaxies. And you can select structured and not merging if the galaxy shows any spiral arms or structure, even if it's very faint, and it is not merging with another galaxy. So this is a lot right now. You know, you may have to do it a few times for it to really sink in, but the beauty of this project is they have a help area where you can ask questions, where you can crowdsource the answers with others and maybe debate them. So it can definitely, and just even looking at it right now, I see an arm right here I can help trace to help them identify the structure of this galaxy.
And these images, so imagine there aren't that many professional astronomers who can sift through hundreds and millions, probably more, of images from telescopes like the Hubble telescope. So all of these images come from something like the Hubble telescope. And so this particular astronomer worked with the Zooniverse platform to make sure they weren't just put online, because that can happen, but developing this type of interface to make it easier for people who are interested in getting involved in the research to actually do things like Caroline is doing right now. Typically, you would go through a couple minute long tutorial to understand a little bit, but you're doing a great job. I have not tried this project yet.
Yeah, I'm just tracing all the arms of the galaxy I see.
Zooniverse also,
This is really good one. This is really clear.
Clear one. So Zooniverse also enables people who would like to be part of their research projects to get credit on their peer-reviewed paper. So the more contributions you make to these projects, if you're motivated by, you know, credit that way in a peer-reviewed journal, Zooniverse has a great platform for that. And then Caroline, I think when you're finished here, do you want to try Snapshot Safari? What would you like to try? I think we could try one more.
Yeah, we're running a little low on time, so maybe we could go to the NLM page just so people can see where they can go to get involved with everything.
Sure.
And for those of you who want to try Globe, because that's one of my favorite projects too, Darlene wasn't kidding when she said that we do Globe a lot at all sorts of different events. You can find Globe in the SciStarter project finder, all the different protocols that Lisa described. So you can work with the Mosquito habitat mapper, land cover, you can use that geometric tool she mentioned to measure the height of trees. And of course, you can identify some clouds, they'll step you through it. You don't have to remember where the cumulonimbus is at the top of your head. You can go ahead and get involved with Globe. It's really user-friendly. So we're going to scistarter.org/NLM. That stands for National Library of Medicine. And this is what we call a curated page. So when you, and I was zooming in to give you all a better view of the project. So my screen view is a little messed up. But the project finder right here, you can click on that, and that's where you can search for Globe and all those different projects and find projects that suit your interest and might be active near you in Philadelphia, or might be online that you can participate in from home. But these projects right here, these are all environmental and human health focused. So this is a good place to go to find Starcatchers, to get involved in that Globe at Night project Darlene mentioned. There are projects where you can document weather and climate, where you can test your pipes to contribute to a national inventory of tap water pipes. It's a really simple kit, just a penny and a magnet, and you're able to see whether or not your pipes are lead. You can do the debris tracker project to help researchers, including researchers at National Geographic, map litter where it occurs and help contribute to a cleaner ocean. So even if you're super inland, identifying like plastic you see and then picking it up can help us understand the flow of plastic to the ocean. Flew Near You, great project out of Harvard. Just by filling out a survey once a week, you can help them understand when the next flu outbreak might be and where it might be. Fold It, this is a project we added recently. you can actually download a program and help build antiviral drugs that might stop coronavirus. It's a little bit more complicated, but it's definitely one where if you volunteer your time, it can be really meaningful. And same with this one, you can solve puzzles and help invent medicine. So develop RNA-based medicines to combat global diseases. You don't even have, that's the beauty of it. You don't really have to even know what RNA is really to follow the protocol and contribute to the fight against global disease. So, and the tutorial Darlene mentioned can be found here as well. So I think, Darlene, do you want to open up for questions?
Yeah, let's do it. We can make everybody's mic hot if you want, or yeah, let's do that.
All right, I'm going to click allow to talk for everyone. So you're all going to have your voices.
Caroline, thank you so much for your overview of all those projects. You do such a great job explaining, and your enthusiasm is so evident, so thank you.
Yeah, and thanks to Darlene for the ongoing opportunities, and Lisa, thanks for sharing your expertise with us today, and to the Union League as well for hosting this and making this all possible. So, any questions from folks?
Lisa and Darlene, this is John Miko. How do you guys know each other?
Well, we, by accident, sort of figured out that we, well, I didn't realize that Darlene lived in Philly. So, through our association with the Globe program and SciStarter, we discovered that. And then I said, well, hey, Darlene, how about if we get together at this place called the Union League? I had no idea that she was so involved, and, her husband, Bob, was on the board. So that shows how, clueless I was about that. But we had such a nice opportunity to meet up for happy hour one evening. So I'm looking forward to being able to do it again.
Me too, Lisa. Me too. Also, somebody on the line has the coolest name in the world, Candy Keen.
Oh, God. Yeah.
That's awesome.
Thanks. A couple years ago, I took an astronomy class up at Drexel, and what's interesting about the website where you're mapping the what are they, solar systems or
Galaxies.
Right, the galaxies. There was a website kind of like that where you were trying to figure out whether the galaxy was spiral or not.
That's right. That's called Galaxy View.
Okay, great. Because I used to tell my kids all about that, my school children, and they would go online and do it because it was so easy to do.
Great.
Yeah. Oop.
But this is very cool.
Candy.
We're glad you liked it. Do citizen science with us anytime. We're very online. I think we have an event on YouTube every day. So come on anytime. We'd love to do citizen science with you.
Thanks.
Bob actually has iNaturalist on his phone. And so iNaturalist is another popular app that helps you, especially for nature lovers and naturalists. You can take pictures of plants and animals. Hopefully everybody can see.
Do you want to?
And then they use two ways to help identify what you're looking at. So if you don't know what you're seeing, so Bob saw a snake and he took a picture of it. And by the time he woke up in the morning, 4 or 5 people had tried to help identify that. And each one of those people who participate have their own ranking in terms of their level of expertise. So before too long, you can start to identify some of the wildlife that you see near you, including plants. The second way that iNaturalist does that is through artificial intelligence. So you can click a button that says, give me an idea of what this might be. That's a really cool app too. So happily, Bob has gotten on board with the citizen science movement as a citizen scientist too.
And you neglected to mention that snake was found at the country club at Torresdale.
Oh. Had all that time to roam around with nobody there, and now it's gonna just leave.
I think we have time for one more question. Does anybody have any comments, questions?
The debris tracker, is that associated with ocean or the ocean concern?
You're cutting off a little bit, but I think I can guess what your question was about the debris tracker app and organizations that are involved with it. There are a number of different lists you can contribute to. So NOAA, the government agency, NOAA, they have a list, and that's the one I usually contribute to, but a number of organizations all around the world are part of debris tracker and get data from it to help understand pollution, debris, litter.
Thank you.
Thank you so much.
Good
All right,
trade.
Darlene, anything else before we go?
No, Caroline has streamed this to YouTube. She's going to send the video over to the Union League so they can post it up on the page where all the other great presentations have been. We'll also send around the links to all the projects that we mentioned here today. And if nothing else, just go to SciStarter, get started in some projects, and definitely download the Globe app. Take care. Nice to see everybody. Happy hour. Thanks for joining us.
Thanks, everybody.
Bye.
Thank you, Darlene.
Thank you.
Thanks, Caroline.
Bye-bye. Bye.